So we're going to talk about simplifying radical expressions. The first thing we need to make sure that you understand to do is the reviewing of the factor tree. So if I started with 54 right here, and then you just pick any two factors. So I picked 6 and 9. You can break 6 down into 2 and 3 and 9 down into 3 and 3. So your prime factorization is 2 times 3 cubed. So we're going to do that with 36. You can start with any. So let's just do the 6 times 6. And then you can break that down into 2 times 3 times another 2 times 3. So basically you have 2 squared times 3 squared as your prime factorization. Number 3, we can start out with, let's do 9 and 14. 9 times 14. And then you can break 9 down into 3 and 3. And then 14 down into 2 and 7. So your prime factorization, you write this in order from least to greatest. So it'll be 2 times 3 squared times 7. Some divisibility tricks. If it ends in an even number, you can divide by 2. If you add the digits and that answer is divisible by 3, then you can divide by 3. If it ends in 0 or 5, then you can divide by 5. And know your prime numbers up to 20. So 2, 3, 5, 7, 11, 13, 17, and 19. So let's go ahead and answer a few of these just as a little review, just to get you kind of practiced up with squares and square roots. So 5 squared is 25. 8 squared is 64. Square root of 81 is 9, because 9 times 9 is 81. Square root of 100 is 10, because 10 times 10 is 100. Square root of 4 is 2. Square root of 20, round to 2 decimals, or round to 1 decimal, excuse me. You just put this in your calculator and you get 4.5. All right, let's take a look at simplifying radicals using prime factorization. So on this one right here, we already know that the square root of 25 is 5, because 5 times 5, which is a pair, gives you the 25. So when there are two matching primes inside, they come out as one whole number. So your answer would be 5. So the square root of 49 is 7, or 7 times 7. So this is two matching primes would come out as one whole number. All right, let's take a look at letter C. Simplified numbers. Some numbers are not perfect squares. Square root of 12 is 3.46410. Simplify. Leave as a simplified radical expressions, not a decimal. So on 12, what we can do is break this down. You could have started with like 4 times 3 and then break 4 down into 2 times 2 times 3. So I'm going to circle a pair and I'm going to bring 1 out. So my final answer would be 2 square roots of 3. And you can also test this. You can put the square root of 12 in and then put 2 square roots of 3 and see if you come out with the same decimal. Letter D, square root of 18. So I started here with 2 times 9 and then broke 9 down into 3 times 3. So a pair comes out, so you have 3 square roots of 2. Letter E, 540. So I've broken 540 down into 2 2s, 3 3s, and a 5. So I'm going to circle a pair of 2s. And then, hang on just a second. This doesn't seem to see E 540. Okay, hold on just 1 minute. I did take 1 away on the original paper, so that's okay. We'll go ahead and just go in with this one. So you're going to take a 2 away and then a 3. So basically you take 1 2 out, 1 3 out, and then you have a 3 and a 5 left over. So 2, whatever you take out, you're going to multiply together. So 2 times 3 is 6. Square roots of 15 is what you have left over. All right, so let's go ahead and practice breaking these down. So you can start with 20. Okay, so I'm just going to start with 4 and 5. You can start with any. I'm going to start with 4 and 5. So 4 times 5. And then 4 breaks down into 2, 2, and 5. So I have a pair of 2s. So my final answer would be 2 square roots of 5. On number 2, hey, anytime it ends in 100, like 700, 800, 200, you just start with 100. So 100 times 7. And then you know 100 is 10 times 10. And so that's your pair. So you have 10 square roots of 7. Now, another way, this is a different way. You can start with 700 and then just start with your highest prime number, which is 7. So 700 divided by 7 is 100. And then 100 won't go into 7, but it will go into 5. That gives you 20, and you can do 5 again. And then 20 divided by 5 is 4, and 4 won't go into 5. So then the next prime number would be 2. So 4 divided by 2 is 2. So, and then you're done. That because 2 is a prime number. So you can't break that down anymore. So I have a pair of 2s and have a pair of 5s. So this would be 5 times 2 is 10, and then you have that 7 left over. So that's just another way that you can break your prime factorization down if you choose to do it that way. All right, number 3, 48. I'm just going to do 12 and 4. So I'm going to start with 12 and 4, and then 12 breaks down into 4 and 3. And then I have my 4. Now, here's something you could do. Instead of breaking the 4s down into 2 2s and another 2 2s, right there is a pair. So you could go ahead and pull that out. So your final answer would be 4 square roots of 3. This is 120. So again, anytime it ends at a 0, I would try to use, in this case, a 10. So 10 times 12, and then 10 would break down into 2 and 5, and 12 would break down into 2 and 6, and then 6 would be 2 and 3. Okay, so there's my 2 and 5, and then right here, 2 times 2 times 3. So we've got a pair of 2s right here, and it looks like that's it. So we have 2 square roots of 2 times 5 is 10, 10 times 3 is 30. 30 is an awful big number, but it can't be broken down anymore. Square root of 21, 3 times 7. They're both prime, so that's it. Okay, so this right here is already in simplest form. All right, let's take a look at problem 6. So 153, I'm going to use 9 and 17. And then 9 would break down into 3, 3, and then 17's prime. So there's a pair. So I have 3 square roots of 17. All right, this one's 300. And again, I told you that if it ends in 100, use 100. And then 100, or the square root of 100 is 10. If you can look at that, it'd be 10 times 10 times 3. There's your pair. So it'd be 10 square roots of 3. 144, this is a perfect square. Square root of 144 is 12. That's your final answer. It is not the square root of 12. It is the whole number 12, because this would be 12 times 12. And so that's your pair you would bring out. A lot of people get those perfect squares confused, and they want to put it back inside a radical, but it's not. It is a whole number.